We are going to start with chapter 2, which we are already doing, but we are going to start with the third presentation today. We will discuss various aspects of simple pendulum in today's class. Okay. Now, if you are going to ask what is a simple pendulum, now a simple pendulum again would consist of a small metal bob which is suspended by an inextensible thread from a rigid support in such a way that a bob is free to oscillate or swing to and fro. I will read it again. It consists of a small metal bob suspended by an inextensible thread from a rigid support in such a way that a bob is free to oscillate or swing to and fro. Now, if you look at the diagram over here, you are having a rigid support with which a hook or some artifact over there is there. Okay. Now, through that hook, you are going to put a thread and you are going to allow a metal object, that is a metal ball, a small metal ball, which serves as a bob for us, is going to hang from this particular thread. Okay, so if you have this particular structure happening over here, okay, so this is known as a simple pendulum. Now, to and fro motion, if you remember for oscillation, okay, what was it? To and fro. If it is able to move like this, then this whole setup is known as a simple pendulum. Okay, now let's go on to the next slide. Now, what are some terms which are associated with the simple pendulum? Let's see, children. Now, first point that it's very important for us to know is, for a simple pendulum, is point of suspension. The point at the rigid support from where the simple pendulum is hung is called the point of suspension. Now, what is it? Now, a rigid support is here from which we have put on a hook, and from here we have hung the simple pendulum. So this is what is known as the point of suspension. Is that clear? All right, let's go on to the next slide now. Now, next term that is associated with the pendulum is what you call as the length of the pendulum. Okay, let me read what I have written for you people. The distance between the point of suspension to the midpoint of the bob is called the length of the pendulum. It is denoted by capital L and it is expressed in the SI units of meters. Now, if you look at the pendulum that is over here, okay, three positions that have been shown. One is here, the other one is here, and the other one is here. Now, what happens is this, again, we learned is a point of suspension for us. Now, the thread that we are tying starts from here. Okay, that is at the point of suspension. What do you call as the length? Starts from here, the measurement, and it goes straight up to the middle of the bob, of the metal bob that you are having. Again, I will repeat, from the point of suspension to the center of the metal bob, it is known as the length of the pendulum, and again it is denoted by capital L and expressed in the SI units of meters. Okay, now next is the mean. What is the mean position of the pendulum? Now, the position of the pendulum or the bob when it is at rest position is known as the mean position of the bob. Now, if you look at the simple pendulum that I have given in this particular figure, it shows that you are having three positions denoted for a simple pendulum. One is right at the center here, the other one is to this side, and the other one is to this particular side. For me, this is supposed to be my right and this is supposed to be my left. So three positions have been denoted here, that is A, B and C. Now, when the bob is, or this particular pendulum is at its state of rest, that is, it is not moving anywhere, it is known as the mean position. Is that clear with you? At the position of rest, this pendulum, when it is known as the mean position of the pendulum. Okay, now let's go on to the next slide, children. Now the next slide says over here, what is the extreme position of the pendulum? Again, as I said, what happens is we are having three positions over here that I have denoted for the pendulum in this particular diagram. It is known as the mean position, extreme position, and the other one again for the extreme position. Now, extreme position is from the mean position if we are moving to the maximum place that it is going to oscillate, or to and fro motion it is going. Now, to the maximum point that it reaches is known as the extreme position for that particular pendulum. Okay, and it starts from the mean position. We take the pendulum to this particular side, it reaches to its extreme position, and it starts moving and swinging like this, that is going so to and fro like this. When this happens, the two ends that it reaches is known as the extreme position. Let's read this definition. The point of maximum distance from the mean position on either side of the pendulum up to which it oscillates is known as the extreme position. Okay, now let's go on to the next slide, please. It is, the term is said to be the amplitude of the pendulum. Now, what is the amplitude of the pendulum? Before explaining, let's read the definition that I have written for you. The maximum displacement of the bob on either side from its mean position is said to be the amplitude of the pendulum. Let me read it one more time. It is the maximum displacement of the bob on either side from its mean position is said to be the amplitude of the pendulum. Now let's look at the diagram. Now this is the point of suspension from which you are allowing this particular pendulum to hang. Okay, now what happens? It is at the equilibrium position, which is at the mean position of this particular, that is, it is not moving at all. Now what happens is the distance that it covers from the mean position to the extreme, again I'll say from the mean position to the extreme position over here, this distance that it covers is what is known as the amplitude. Now again, it doesn't happen only on this side. Obviously, it means that if from the mean position at this particular place, if it is going to get displaced or is going to move to this particular to the right side as well, so the maximum distance from the mean to the extreme, or the distance between the extreme and the mean, is what is known as the amplitude of the pendulum. Okay, now what do you mean by one oscillation of a pendulum? What is one oscillation of a pendulum? Let's try to understand this. I will read it. I will make you understand over here through this particular diagram. Then we will read what I have written for you. Now, obviously, this is the point of suspension. You're having the pendulum over here at the position of rest. Two extreme positions I have denoted over here, or given in the figure, is A dash and A double dash. Okay, now what is one oscillation for us? It means that if the pendulum is here, you're going to take it to this extreme side, that is at A dash, and leave it. Okay, what will happen? From the mean, it goes to the extreme, then again it goes to the other extreme, and then when it comes back again to this is the first extreme. I will repeat. Starts from the first extreme, okay, goes to the second extreme, comes back to the first extreme. When this motion happens, it is said to be one oscillation to have been completed. I will repeat. From one extreme, it goes back to the second extreme, and that again, then again back to the first extreme. When this particular motion happens, it is known as one oscillation of the pendulum which is happening. Are we clear, everyone? Okay. Now let's read what I have written for you guys. One oscillation is the movement of the pendulum from one extreme position to the other extreme position, and then back to the first extreme position. One extreme to the other extreme, that is the second extreme, and coming back again to the first extreme. This thing that is starting from here, going, coming back here, is one oscillation. Okay? Now, in terms of the position I have written, we start from A, go to A double dash, or we go to A dash, okay, and then come back again to the excuse me, and then comes back again to the second mean position, then goes to the second extreme, then comes back again to the first extreme. फिर से first extreme to the second extreme, back to the first extreme. This is one oscillation. फिर से one extreme to the second extreme, coming back again to the first extreme. This is one oscillation. I hope this is clear to everyone, because this is very, very, very important for you to understand, so that which is very important for the rest of the terms that is going to come for you right now. Okay, let's go on to the next slide. Now, another term that is very important for you over here is what is half an oscillation. Now, we have studied one full oscillation. Let's understand what is half an oscillation. Okay. Now, half an oscillation, let's read first. Half an oscillation is the movement of the pendulum from one extreme position to the other extreme position. Okay. From one extreme to the other extreme. Remember, in one oscillation, I had told you it is one extreme to the second extreme and back again to the first extreme, whereas in half an oscillation will be exact आधा of what I said in one oscillation. यानी मैंने one oscillation में कहा first oscillation से first extreme से second extreme से first extreme, ये एक हुआ, उसका आधा हुआ one extreme से दूसरा extreme. That's it, and your half oscillation finishes right there and then. Now in the figure over here, what happens is, if this A and B over here are the two extremes for it, it starts with A, goes to B, half an oscillation finished. Whereas one oscillation would have been from A to B, B to A. That would have been one oscillation, whereas half an oscillation is going from one extreme to the other extreme, and that completes the half oscillation. I hope this is clear, children. Okay. Now let's go on to the next term, which is related to the same oscillation. What is 1/4 of an oscillation of the pendulum? What is 1/4? Okay. Now let's read. 1/4 of an oscillation is the movement of the pendulum from the mean to either of the extreme positions. यानी एक oscillation का एक fourth, यानी कि एक चौथाई हिस्सा क्या होता है? एक चौथाई हिस्सा oscillation का क्या होता है? Let's understand that again. हमने कहा एक ऑसिलेशन क्या हुआ, एक जगह से दूसरा एक्सट्रीम फिर फर्स्ट एक्सट्रीम. हाफ ऑसिलेशन वन एक्सट्रीम टू द अदर एक्सट्रीम. अब उस हाफ ऑसिलेशन का हाफ कितना हुआ, फ्रॉम द मीन टू ईदर दिस एक्सट्रीम or from this mean to this extreme. That's it. Now we learned one oscillation. Now in this figure again that is being shown here, A, B and C, three positions are here. Now आपका B is the mean, A and C are the extremes. Okay, so what happens is, again I will with the help of this figure, let's understand one oscillation. A to C, C to A, one oscillation. Half an oscillation. A to C, half an oscillation. 1/4 of an oscillation. A to B. That's it. Now again, I have started all these motions from one extreme, which is said to be A. You can obviously start from the other extreme also, which is C over here in any of the diagrams. But I just started from my left to go to the right. Are we clear with this, everyone? Okay. I hope, and please understand this. These are things which will be asked in your examinations. So you need to take a note of this whenever you are studying this. Are we clear, children? Okay. Let's go on to the next one. Okay. Now the next slide has the term which is said to be time period of an oscillation of the pendulum. Now, what is the time period? Let's see what the writer that I have given for you is. Time taken by the pendulum to complete one oscillation. Simple. एक oscillation complete करने के लिए जितना वक्त आपको लगता है वो आप कहते हो time period. Again, time taken by the pendulum to complete one oscillation is said to be the time period of that particular oscillation. All right, children? No issues in this understanding at all. Now, it is denoted by capital T, and in SI units, it is measured in seconds. Okay? No issues. Now, again, the diagram that I have given. Main position is at 0. Extreme positions are at A and B. One oscillation per se. Let's do it again. A to B, then to A. All right. Now, the time taken to do this, that is go from A to B and then come back to A, is the time period of that particular pendulum, because that is the time taken by the pendulum to complete one oscillation, and that is again denoted by capital T over here. Okay, let's go on to the next slide, children. Okay, another next topic and another important one again for you people is, What is the frequency of an oscillation of the pendulum? What is called the frequency? Okay. Now, the definition is, official definition of frequency is that it is the number of oscillation which is made by the pendulum in 1 second. Okay, it is denoted by small f or small n, or it's a Greek symbol. Basically, it is called nu, but we have written small n over here because you're not familiar with that term, and it is measured in the SI units of hertz, which is denoted by capital H and small z over here. ठीक है? Now, टाइम हमने अभी पढ़ा कि आपका कितने सेकंड्स में एक ऑसिलेशन होता है, ठीक है ना, कितने सेकंड्स में एक ऑसिलेशन होता है. अब उसी चीज को अगर हम लेके चले, एक सेकंड में कितना ऑसिलेशन होता है. आर वी गेटिंग माय पॉइंट? टाइम टेकन इज in one oscillation how much time is taken, whereas frequency is एक सेकंड में कितने ऑसिलेशन होते हैं. दिस इज द बेसिक डिफरेंस बिटवीन फ्रीक्वेंसी एंड टाइम पीरियड. ठीक है. Now let's go on to the next slide, please. Now this is quite an interesting slide that I have put together for you children. Okay. Now this is a very important thing that you need to be knowing about it, and you should be aware of it as well. Is what is the relationship between, or what is the relation between the time period and frequency of a simple pendulum. Now when you look at it, it is f is equals to 1 by t, यानी कि जो frequency होता है is equals to 1 by time period, or if you are going to change the positions of these two t and f, what do you get? T is equals to 1 by f. That means that they are reciprocal of each other. Always remember. Now over here I have given some values. Okay, what you need to do is just check out whether these values are exactly the same as according to the formula that I have given, which means अगर मैंने आपको फॉर्मूला दिया हुआ है, ठीक है, तो आपने क्या करना है, फ्रीक्वेंसी मैंने दिया है आपको 0.5 हर्ट्ज, और आपने इस फॉर्मूला में इसे डालना है, एंड यू नीड टू फाइंड आउट वेदर योर टाइम कम्स टू एज इक्वल्स टू 2 seconds or not. ठीक है. Now another one over here is again the same thing. If you are going to take the frequency as equals to 1 hertz, how much time period will you get? Okay. Now it is, if you are going to put 1, this is very simple, 1 divided by 1, obviously you are going to have the time period as equals to 1. And now like this, if you are going to substitute the values in either of the formulas, you will get the value of the other one. That means that if the time period is given, I can ask you to find the frequency, or if the frequency is given, I can ask you to find out the time period. Now this is something which numericals basically I'm very keen on asking, and you should know it because you will be using this formula in your higher classes, so you should be aware of it. Now again, just few things of the very same thing I've put it over here is, आपको hertz जो है, आप जो कहते हैं उसको per second भी क्यों कहते हैं. Now the other unit that you are going to use it for hertz, you can also call it as per second or second to the power -1. Let's see how do you do it. 1 hertz, again 1 hertz is written as equals to 1 hertz in the form, in the symbol or the value that you have it for hertz, that is z, it is represented as hertz. हमने कहा 1 oscillation per second, 1 oscillation per second, that is एक oscillation एक second में, यानी कि हर एक second में कितना oscillation. So what you are going to get it is 1 divided by second, or 1 second to the power -1. So 1 hertz का एक और value होता है seconds में, उसको आप कहते हो second to the power -1. All right. Now again, this formula that I have given, that is f is equals to 1 by t. Okay, any one of them over here can be used for you people to find out this particular thing, that is the relationship between f and t. Values given, you can use it to find the value of the other identity that I am asking in the question. Is that clear? Now the next slide that we are going to discuss in our activity 6 is the activity 6 in our textbook. How do you measure the time period of a simple pendulum? Now I will just read the activity. Okay. Now, the time taken by a pendulum to complete one oscillation in very short time is very short and it cannot be measured accurately. In order to find the time taken by the pendulum for one oscillation, we measure the time taken for completing the large number of oscillations, say 25. This can be easily and conveniently measured by a stopwatch. Then we divide this time period by 25 and find the time period for that oscillation. Now, what are the steps that are taken in that particular regard? Okay, I will read it again, children, and you need to read it again in your textbooks along with it. The first point says is what are the steps that are taken. Now, basically the gist of this activity is आपको accurately कैसे आप time period measure कर सकते हैं आपके physics lab में. ना experiment का ये activity का मतलब है एक oscillation का time period निकालना is very accurately निकालना very difficult होता है. तो आप करते क्या हैं यहाँ पे या हम लैब में करते क्या हैं, हम एक की जगह पे 25 ऑसिलेशंस का टाइम पीरियड निकालते हैं. उसके बाद उस सबों को हम डिवाइड कर लेते हैं, एवरेज ऐड कर लेते हैं पूरे टाइम को और उसको 25 से डिवाइड कर लेते हैं ताकि हमें एक ऑसिलेशन का टाइम पीरियड पता चल जाए. आर वी क्लियर विद दिस? दिस इज वेरी क्लियर एंड वेरी सिंपल. एक टाइम पीरियड निकालना is difficult, so what do you do is you find it for 25, all right children, and then you are going to divide it by 25 to give us the accurate number what is required for that one oscillation time period. Clear? Now let's read this steps that are given. First is the pendulum is moved to one end and released and thus setting it into oscillation. That is, we take it to one from the mean position, we take it to the extreme and we release it so that it starts getting into the oscillation mode. Now, when the bob reaches the other extreme position, a stopwatch is started. यानी कि एक एक्सट्रीम हाफ ऑसिलेशन इसका होने वाला होता है, आप अपना स्टॉप वॉच चालू कर देंगे यानी कि उसे ऑन कर देंगे. इसका मतलब है ये 0 रीडिंग हुआ आपका. ओके ना, आपका एक ऑसिलेशन कब हुआ यानी कि एक एक्सट्रीम से दूसरे एक्सट्रीम से कमिंग बैक अगेन. ना, दिस इज द टाइम टेकन फॉर वन ऑसिलेशन. ना, इस तरह का मोशन वो 25 टाइम्स जो करता है वो हम उसको मार्क करेंगे. क्लियर ना? इसके बाद में what are we going to do is we are going to find the time taken to complete 25 oscillations. Then you are going to divide it by 25 and you will get the time for one oscillation. And by this activity you find out an almost accurate value for the time period of a simple pendulum if you are going to calculate it in large numbers. Is that clear? As simple as that, nothing more than that is there in this activity. Now let's go on to the next slide, please. Okay, now the next slide is, the heading for it is, what are the factors which affect the time period of a pendulum? First I have written is the length of the pendulum. The second is acceleration due to gravity. I hope everyone knows that the formula of the time period of a pendulum is equals to, that is T, that is time period, is equals to 2 pi into root over L by G, where T is the time period, pi is the 3.1422 by 7, a mathematical identity which is a constant quantity, okay, and L, which is under the square root, is the length of the pendulum, and G is the acceleration due to gravity. Is that clear? Now a big question arises here, why is this quantity involved over here, that is acceleration due to gravity is involved in this? Now simple thing is, if you look at the pendulum, it is hanging down. Anything that is hanging down, all right, has the tendency to go towards the center of the earth. Now if any object has the tendency of coming from the top and coming right bottom, is going to experience this acceleration due to gravity. All right, we have already determined this, and that is why the quantity of G is brought into this formula. Now how is it incorporated into this particular formula? We are going to deal with it and get to know about it a little later. All right, now the first factor over here, okay, the dependence of the time period on the length of the pendulum. What do we find is the time period of the pendulum is directly proportional to square root of the length of the pendulum. Again I will say, time period of the pendulum is directly proportional to the square root of the length of the pendulum. What does that mean is time period is directly proportional to the square root of the length of the pendulum. All right. Now what it means is if you increase the length, time period also increases, or if you increase the time period, the length is also going to increase. That is, the square root of the length is going to increase. Now, you must find this a very, a peculiar explanation, but let's read this. It is for this reason that the pendulum clocks go slower in the summer season as the length of the pendulum increases due to the expansion effect of the heat, which in turn increases the time period. Now, did you know this? Did you know this particular fact? Again, as I said, was a peculiar one for you. Now, what happens is during summer season in the pendulum clocks, the length is going to increase. Now, why is the length going to be increased? The length is going to be increased because of the effect of the heat, which causes it to expand. When it expands, what will happen to the length? It's going to increase. Now, when the length is going to increase, what will happen in turn happen to the time period? This will also increase, but in the capacity of, if the length is going to be increased over here 4 times, what is the number of times by which the time period is going to be increased? Is going to be increased 2 times, because square root of 4 is 2, so time period is going to be increased with 2 times. All right, is that clear with everyone? Okay, so this is what I mean over here is time period is directly proportional to the square root of the length of the pendulum. And again, very valid reason again over here why the pendulum clock over here swings slowly and it loses time during the summer season. Is that understood? I think that's enough for today. When we are going to meet again in the next class, we are going to discuss more. All right, so thank you.